This is the Discovery Files podcast from the U.S. National Science Foundation. The word quantum is defined in two ways. One, as a noun meaning a small quantity or portion, and two, as an adjective meaning large or significant. In quantum computing, a qubit can be both 0 and 1 at the same time, on and off, small and large. The world of quantum seems full of mystery. To learn more, we spoke with quantum physicist Dr. Spiros Michalakis, a staff researcher and manager of outreach at IQIM, the Institute for Quantum Information and Matter at Caltech. Dr. Spiro, thank you for joining us today.
Thank you for having me.
How did your role at the Institute for Quantum Information and Matter, a National Science Foundation Physics Frontiers Center, bring you into the Marvel universe?
It's actually a pretty interesting story. This started about 8 years ago now, and it was an interesting coincidence that one of my colleagues at Caltech, Sean Carroll, was connected to an organization known as the Science and Entertainment Exchange. This is a program of the National Academy of Sciences, bringing together scientists like myself with Hollywood producers, executives, writers, directors, try to inject some more science into the movies that we see. And Sean introduced the director of the exchange to me, and then we just took it from there. He called me actually July, I think it was end of July, beginning of August of 2014, with the following proposition: would I fly out to Atlanta, where Pinewood Studios is, where a lot of the Marvel movies are made, to be part of a new Marvel superhero movie known as Ant-Man. I wasn't sure who Ant-Man was. I hadn't read Ant-Man comics at the time. But he ended the call by saying that maybe Paul Rudd would be there. And so that clinched the deal for me. And I flew out a few days later, and the rest is history.
Suspension of disbelief is important when you watch films. What are the challenges in bringing real science into Hollywood?
I've gotten this question a lot over the years of how important is the scientific accuracy in movies like this. And my answer is always the same, that as long as it inspires, as long as it grounds the dramatic elements of the plot into something that is exciting, right? It deepens, I guess, aspects, the texture of the movie, so that when you leave the movie, you don't just forget about it within an hour or so. It stays with you, right? There are some visionary filmmakers. Usually they're also the ones who write the movies. They're the Christopher Nolans of the world, right? James Camerons, Alex Garlands, Steven Spielbergs. We know these names, and the movies stay with us for a long time because they take the time to try to get things not scientifically accurate per se, but to work with experts to deepen the wows, right? The moments that blow our minds. And for me, for my own scientific journey, interestingly enough, it was Star Trek that got me to switch from mathematical biology, which is what I was studying more at MIT as an undergraduate student. And then when I went to UC Davis for my PhD, I thought I would be continuing the same research, but then the head of the math department asked me if I wanted to work instead on quantum teleportation. And I thought he was making it up, to be honest, but I heard teleportation. I was like, if this is a real thing, I want in. And it wasn't a real thing in Star Trek. There is no accurate depiction of teleportation in any movie, including Interstellar, right? But it was inspiring. It was inspiring, and I thought like, well, if there is a way, I would like to be part of this scientific endeavor that makes this happen one day.
Which begs the question, what is quantum teleportation?
Yes. Quantum teleportation, the scientific aspects of this have to do with a particular protocol, and you can run an experimental protocol to transfer information, quantum information, by using what we call a side channel of classical information. So it's a way of transporting information that is very hard to transport otherwise between two very distant places across the Earth or the universe. But often we think of it as being different than what you see in the movies, where you just disappear from one point and reappear on the other one. But to me, quantum teleportation is very mind-blowing because it tells you that there's something interesting going on. There's this other resource in the universe known as quantum entanglement, which I put into the second Ant-Man movie, Ant-Man and the Wasp. And this is a very real resource. It sounds like magic, but it seems to be the thread that connects everything with everything else, like including space and time. Even in empty space-time, there seems to be entanglement. And we're now trying to figure out how to manipulate it, how to exploit it at larger scales, which is also what we're doing at Caltech's Institute for Quantum Information and Matter. And it's one of the main resources also that we're trying to manipulate to create quantum computation at scale and also other really cool quantum technologies.
Science fiction and Star Trek in particular have impacted so much of the science of today. Do you think the science fiction of today will impact future researchers the same way?
I hope so. I hope that research will impact the kind of movies and TV shows that we see into the future and the other way around. Just like Star Trek had an impact on me, and the truth is that I didn't even watch that much Star Trek. It was just so pervasive, and everyone knew about Beam Me Up, Scotty, right? It was part of the mainstream language, that it was good enough to get me to change my life's work at the time to follow this new path. And I'm so glad it happened. But I also think that we give back. I hope that my work with Marvel, helping to introduce the quantum realm, some of these concepts, will make a difference one day for others who want to work and jump into it. But I do believe that this dialectic, this connection, whenever we have connection between different worlds that are not supposed to talk to each other, they come from very different parts, right? They have very different perspectives about what is valuable, what is needed. Whenever we build bridges and we create trust within these worlds, for example, the world of academia and science and the world of entertainment and Hollywood, I think this is when magic happens, when true magic happens, right? And there's a win-win situation. It amplifies the value of both sides. And I hope to see a lot more of that.
It really helps to capture people's imagination about what is and what could be.
Exactly. That creative process. I've had some friends who are celebrities these days, and sometimes they will text me and say, Spiro, tell me a little bit about your process as a scientist, because they will be playing a scientist on a show, right, or a movie. And when I tell them what it feels like, they're like, but this is exactly how being an actor is, right? Being an artist. And I find this fascinating. I love hearing that.
How did your role at IQIM get you involved in bringing quantum mechanics into gaming?
Yes, this was another interesting path. At some point, Google reached out to me. I think it was 2012 or 2013. It was like more than a decade ago. This is exciting to go back in time. And they asked if I had any ideas on how to help them connect with the public, because they were interested in getting into quantum computing at the time. And I decided that it would make more sense for us to go to where the public is, especially where the next generation was hanging out, and to try to bring them to us. And everyone was hanging out on Minecraft at the time, right? All the kids. So I thought, why don't we just start by going inside of the game, working with Mojang, the company that made Minecraft, to bring quantum physics into the game through a mod, right? A modification of the main game. And it became very popular. It had like millions of downloads, a lot of videos by Twitch streamers at the time. And it was really nice to see also. I would go do outreach to schools, and I would bring along the new mod and the world that we had built around it. And the kids loved it. They would always congregate around the laptops that had QCraft, which was the mod that we created for quantum physics within Minecraft.
And I understand you've moved into quantum chess a little bit now. Can you briefly explain what that is?
Yes. One good thing leads to another. right? So because I was, I guess, at the time a world expert in making quantum games, since there weren't any other ones, a graduate student from USC near Caltech found out about me and then Chris Cantwell, came to me and said, I have an idea for a different game. And he showed me a small board that he thought would be interesting to extend one day maybe to quantum chess. And we spent a couple of months thinking about how realistic this could be to build a game as complex as chess, but with actual quantum physics as what we call the game engine. And we were able to pull it together. And once we have something, then we actually reached out to Stephen Hawking and Paul Rudd. And then I was able to get Keanu Reeves, who's now a friend, involved in doing voiceover for a video where he brought all of that together. And the cool thing is that all of that was funded by National Science Foundation. The full video, and we brought it together within a month for an event that we were putting together at the time at Caltech back in 2016. And it was really fun to see everyone get so excited to do something like this. Again, having Paul Rudd, Stephen Hawking, Keanu Reeves, these were individuals that usually did not work together, right? Did not know each other, but everyone was so excited to be part of this process. And it was because of this quantum game, the quantum chess, that has evolved over the years now and has gone way further.
In Minecraft, for example, how does a quantum game differ from a regular game?
Minecraft, it's all about mining different ores and building different blocks and being able to put them together to create buildings, tools, all this stuff. So we actually introduced a new ore in the game that you could mine in special places called a quantum ore. And this ore would allow you then to create new blocks that had the ability to be entangled, that whose actual material, depending on how you observed it, from which angle you observed it, you could also have them disappear. You could fall through. You could create really interesting traps, buildings that appear and disappear depending on how you're looking at them, entangle them, teleport. We actually created the quantum teleportation protocol in the game. The kids really loved that.
I see a lot of references with AI and quantum kind of closely related. Is there a connection between AI and quantum science?
That's a great question. So AI has to do more with what we call now machine learning. It's part of computer science. It's a way of training, I guess, computers on vast amount of data to be able to predict, say, the next move in chess, right? Or even quantum chess. We're just building an AI for quantum chess as a game as well. With quantum, it is again kind of a theory of knowledge, but also it is very powerful through quantum computing and what we also call quantum information theory, to be able to shift through some of that data in a much more interesting way. And you can imagine getting superpositions of all possible chess games and being able to glean from these quantum superpositions strategies that you wouldn't be able to do otherwise, because you would need massive supercomputers to shift through each game individually. And there's research done also at IQIM, where I work, really nice research, to figure out exactly how quantum physics and quantum computing can amplify all of these machine learning and AI algorithms that are out there to make them way more efficient. And there's some really nice results, but it's still like very active area of research.
Let's move into some of the fundamentals for people that don't know anything about quantum. What is quantum physics?
Quantum physics, this is one of the hardest questions to answer, but I will answer it this way, a bit more philosophically, and I think maybe in a way that can connect with individuals who haven't studied all the mathematical background. To me, quantum physics is the ultimate theory of knowledge that humanity has come up with. It looks like and feels like another theory of physics, but it's actually a theory of knowledge, a very powerful, very general one, a framework within which you can understand any universe, whether it has the space-time structure of ours or no space-time at all. And it's really interesting when you see it from that point of view, because when you go to the foundations of quantum physics, the mathematical ones, and space and time kind of go away and then re-emerge in equations that were developed 100 years ago, when individuals like Einstein and Schrödinger and Heisenberg thought that the foundation of everything was space and time. But as the mathematics evolved, we kind of got rid of space and time, and then we're now trying to figure out how space and time emerges from deeper quantum concepts. Most people know of quantum physics as just being a theory of physics of the subatomic realm, right? Of the smallest particles, where things can be at two places at the same time. They can be connected and tangled with each other over vast distances. But these are epiphenomena. These are things that emerge from the more foundational aspects of the theory, which simply says that if you want to know what any universe looks like from the point of view of two different observers, then you may actually realize at some point that these observers maybe think that they're asking independent questions, and hence they can get independent answers, but actually they're connected. So the order in which they ask these questions, the order in which, the way with which they interact without even realizing to try to observe what is outside of each of them makes a big difference. And that is a fundamental aspect of the quantum universe, where the observer affects the observation. It wasn't always there.
A lot of the things we read about quantum are speculative or theoretical. What are some of the things in the quantum field today that are real?
Yes, in fact, many of the technologies that we use every day, GPS, MRI, so many other things, lasers, would not exist without an understanding and use of quantum physics. Besides that, the most real thing of all, the universe, is fully quantum, right? Everything, all particles and the fields of which they are excitations, exist within the quantum realm and part of the quantum realm. It is so pervasive that it is invisible to us, right? Both because of our frame rate and zoom as human beings, we don't realize that everything going on around us is quantum. And it's just a synthesis of many, many quantum events happening very, very fast. But when we slow things down and we start exploiting these powerful resources, then we get things like quantum computers. And this is something very fascinating, very exciting for the world, for the United States also. We're trying to create these super powerful computers that leverage these new resources that were always there, but now we're finally revealing them and learning how to handle them. Quantum entanglement, quantum superposition, to create new algorithms that can help us solve problems that would have taken us the age of the universe otherwise. And we should be able to do them in a few days these days. So that's very powerful. That's very real. It's happening now. But then we have also other technologies, like trying to measure signals coming from faraway galaxies with much higher fidelity, being able to capture even from a few particles of light, photons, information that otherwise would have been impossible by using quantum aspects of these particles.
Finally, how will quantum science impact society?
For me, quantum science, quantum physics specifically, it is the language of the universe. It is the language that the universe itself speaks to itself. It is fluent, native, right, in that language. And because of that, it is really powerful when we try to learn how to speak that language ourselves, because humans, we're more stuck over thousands of years speaking a classical language, the regular language of physics. It is very intuitive to us and comes from most of our experiences every day. But by learning how to speak this new language, our minds also change. Our minds change in really wonderful ways, because you start to think in much more expansive ways. For me, specifically, beyond all the technological advancements from quantum physics and quantum science, quantum physics is not just a theory of physics or even a theory of knowledge. For me, it is the ultimate theory of empathy, which is very strange for most people to hear, that quantum physics has to do anything with empathy. But in my opinion, what makes it so powerful is that it requires, almost demands of us, to look at the world from new perspectives that we thought were unimportant, false, right? Uninteresting, take too much energy for no reason, to try to see the world from these other ways. But when you're doing quantum physics, you realize often that taking on these new perspectives allows you to really get to the essence of a physical phenomenon way faster. So for me, the big picture is that quantum physics will allow us to develop our empathy as human beings, because if the universe uses it all the time to try to do all these amazing things, then I think it's good for us too.
Thank you so much for taking the time to join us today.
Thank you so much for having me. It was fun.
Special thanks to Spiros Michalakis, Gina Scofidio, Matt Christensen, Tim Allen, Adam Eggers, and Dina Headley. For the Discovery Files, I'm Nate Podker. You can watch an expanded version of this conversation on our YouTube channel by searching at NSF Science. Please subscribe wherever you get podcasts, and if you like our program, share with a friend and consider leaving a review. Discover how the U.S. National Science Foundation is advancing research at nsf.gov.